Okay, so I'm going to try and do kind of a quick lesson over this one. Just kind of nitty-gritty, get it done. So Kentucky HSG1, we're still working with this standard. We're understanding properties of line segments. So if you take a look over here, we're talking about the addition postulate. And we've got a definition to start out with. It says if 3 points A, B, and C are collinear and B is between A and C, then, well, let me draw this picture. So collinear means they lie on the same line, so we need a line. So there's our line. Did not mean to do that little mark there. And I've got A, B, and C. And what I have with what this postulate is talking about, if 3 points A, B, and C are collinear and B is between A and C, then the measure from, or the distance from A to B plus the distance from B to C is going to equal the entire distance. Okay? So this distance plus this distance equals the entire distance. And this is something that might seem intuitive. It's just harder to talk about and harder to quantify whenever you're first starting out, so it just takes a little time. So we got our first example. It says BT equals 36, and yeah, they're referencing Batman. So Batman is pretty cool, I guess. I like a lot of the video games. They're pretty fun. And they give us on their curriculum online, 8x minus 14 is this distance, okay? So they tell us that that expression represents that distance. And then they also tell us that from A to T, this distance here, it's going to be 2x. The expression 2x represents that. And down here, it's asking us to find BA and AT. Okay? And they also give us that the distance from B to T, this entire distance is 36. So I'm going to draw that in as well. So this entire distance is 36. Okay? So what do I have? Well, I have from that addition postulate, I've got BA, the distance from B to A, plus AT, the distance from A to T, is going to equal the entire distance, which is BT. Okay? So from here, I can start to plug and chug things in. So I've got BA is 8x minus 14. So this distance, 8x minus 14, plus AT, which is 2x. So that distance equals BT, the entire distance, so 36. So from here I can start to solve this equation. I can break those parentheses. I really don't need them. I'm just showing that you are substituting 8x minus 14 in for BA. So 8x plus 2x is going to be 10x. Minus 14 equals 36. So what I want to do is I want to get all the like terms to one side, and I want to isolate that variable. I want to get that alone. So I've got negative 14 here. So subtraction of 14, the opposite is adding 14. So I'm going to add 14 to both sides. So I get 10x equals 50. So from here, since 10x equals 50, I've got to get rid of this 10. I'm going to divide both sides by 10. So that gives me that x equals 5. Okay? So since x equals 5, what I can do is I can find the measure of BA and AT. BA, they said, was the expression 8x minus 14, which is the same as 8 times 5 minus 14, which is going to be 40 minus 14. That's going to be 30 minus 4, so 26. So what I have is that entire distance up there for the first part it's kind of like a puzzle. I figured out that the distance from B to A, is 26. And then I can also find AT, right? AT is given by the expression 2x. I know that x is 5, so this is 2 times 5, so that's 10, okay? So that entire distance there is 10. And I'm good. And so over here, they want to know something pretty similar. So they've got MA is 5x minus 3. They give us that AN from A to N is 30. And then on the curriculum, if you go watch their video, they also tell you that MN, the distance, the entire distance from M to N, is 8x plus 6. That entire distance. So I've got MA plus AN equals MN. So that's the addition postulate. So the distance from M to A plus the distance from A to N is going to equal the entire distance from M to N. And then I'm just going to plug and chug from there. So I've got 5x minus 3 plus 30 equals 8x plus 6. And from here, I'm just going to combine like terms. So I've got 30 and a negative 3, so they combine to be 27. So 5x plus 27 equals 8x plus 6. So I'm going to move all the variable terms to one side. I'm going to swap the equations. I'm going to put 8x plus 6 over on this side and 5x plus 27 over on this side, just to bookkeep for myself. And I'm going to continue here in a second over here. But the next step I want to do is I want to get all the x's on one side of the equation. So I'm going to subtract 5x from over here and over there. So I get 3x plus 6 equals, and I'm left with 27 on the right-hand side, so 27. So what I want to do is I want to get rid of this positive 6, I want to get rid of the constant term, and I want to get rid of this 3. So I'm going to undo that addition of 6. So I'm going to subtract 6 from both sides of that equation. I get 3x equals 21. And then from here I can divide both sides by 3. And x equals 7. So I found x. And you can also find the distance from M to A and the entire distance from M to N if you wanted to. So I'm going to leave that to you as an exercise if you want to do it. It doesn't ask for it. So down here I've got a quick review of solving equations, something they created. So for this equation, first thing I'm going to do is subtract 1 from both sides of this equation, and I get 2x equals 8. So then I've got 2 in front of that x. I've got 2 times x equals 8. So to undo this multiplication, I'm going to divide both sides by 2. So this gives that x equals 4. And there you go. Over here, I've got some like terms to combine. So I've got 2x minus 5x. Well, 2 minus 5 is negative 3, so that's negative 3x plus 1 equals 9. So then I want to get rid of this addition of 1 here, so I'm going to subtract 1 from both sides of that equation, and I get negative 3x equals 9 minus 1 is 8. So then I've got a negative 3 times x. I want to get rid of that negative 3. It's being multiplied by x, so I'm going to divide both sides by negative 3, and this gives me x equals 8, negative 8 over 3. So negative 8 over 3. So the negative 3's divide out to 1, 8 divided by negative 3, and I can leave it as a fraction. That's perfectly fine. Over here, I want to get all the variable terms on one side, so I'm seeing this negative. I want to change it to a positive, so I'm going to add 3x to both sides of that equation. So 2x plus 3x is 5x, plus 1 equals 11. And then I want to solve for x, so I want to get rid of this addition of 1, so I'm going to subtract 1 from both sides. So I get 5x equals 10. And then I can divide 5 on both sides, so I can get rid of this multiplication of 5, so I'm going to divide 10 by 5, and I get x equals 2. And that is perfectly acceptable. Probably should box that one too. And then over here, I've got a nasty equation. Just doesn't look great. So I'm going to combine like terms to start off with. So 2x plus 3x is 5x. 1 plus 4 is 5. 19 minus 5 is 14. So I've got 3x plus 14. So then I'm going to get rid of this 3x and move it to this side of this equation, combine those terms. So I need all the variables on one side. So I'm going to subtract 3x, subtract 3x. 5x minus 3x is 2x, plus 5 equals 14. I've got an addition of 5, so to undo that addition, I'm going to subtract 5 from both sides of that equation. So 14 minus 5, it's going to be 9. So I'm left with 2x equals 9. And then I can divide 2 on both sides, right? 2 is being multiplied by x, so to undo that, I'm going to divide both sides by 2. So there's plenty of videos on solving equations out there. That's just a quick refresher. Hopefully you followed along. If not, I'll put some videos up. There should already be one under Algebra Unit 0 on my YouTube page. And it is using Flip Math, so I can't take credit for any of the curriculum. I'm just doing some of the work so I can help my students out. So Algebra Unit 0 should be lesson 0.1. So that's just, again, going off Flip Math's curriculum. And they have done something amazing. I love this curriculum. It's great. It's really nice. Okay. If point B is in the interior of angle DOG, so let's draw angle DOG. So that's O. Over here is going to be G. And this is D. And they said point B is on the interior. So I'm going to let me draw that G nicer. Like, what is that? That is a swirly. There, that's better. And then right here is B. So it's on the interior of that angle, right? It's between the two rays. If the rays continue out, it's on the inside of this interior. Then, well, we have the measure of angle DOB. So I'm going to draw a ray out from O to B so you can see that. Measure of angle DOB, this angle, plus the measure of angle BOG, this angle over here, not necessarily the same, is going to equal the entire measure of angle DOG. So it just means if you've got two angles, if you got a big angle here like this MAH here, that means the measure of MAT plus the measure of TAH is going to add up to be the entire angle MAH. Okay, so this is like kind of using those algebraic skills to try and solve for different variables using these addition postulates, and kind of get your mind in the mindset of two angles on the interior will add up to the entire big angle. So angle 1, angle 1 plus angle 2 equals big angle. That's kind of the idea. Small angle plus small angle equals the big angle. Yeah, that's what I want to say. Okay, just writing some of this down. Here, angle MAT, they say it's 60. So this angle here is 60. And then they also have that TAH, they give us that that's an algebraic expression, 4x plus 20. So they tell us that that angle is 4x plus 20. And then if you watch their videos, they give angle MAH to be 140. Okay, so I'm not pulling that number out of thin air. That's what they intended to put there, but I guess they're hoping for some guided notes. So will I. So that's 140. And they want you to find x. So we are going to find x. There he is. He's right there. He's been there all along. That's where he was hiding. No, that's not good. Okay. So I've got from the angle addition postulate that the measure of angle MAT, that's this angle, MAT, plus the measure of angle TAH equals the measure of angle MAH. So that entire big angle. So angle MAT is going to be 60 degrees plus the measure of angle TAH, which is 4x plus 20, is going to equal the measure of the big thing, which is 140. So equals 140. And so from here, if you're familiar with solving equations, you just solve it out. So I'm going to combine like terms on this left-hand side. I've got 4x plus 80 equals 140. And I'm going to subtract 80 from both sides of that equation. And let's see, I get, 60. 4x equals 60. So then if I divide both sides by 4, I get x equals 15 degrees. And so if I wanted to, I can go back and I can figure out these angles. Another thing is if you can kind of reason through this, you don't have to solve the equation, I think, for this one. And maybe some of the other ones you might be a little brighter than I am to solve using your brain, but just thinking about it. I know this is 60. I know this has to be 140, so I can say this is 80. So 4x, 80 minus 20 is 60, so x would have to be 15. So you can kind of reason through it. And you can find out just from the start that that angle would have to be 80. So sometimes it's helpful to use those skills, especially if you're taking a test. I have no issues with you using some logic to try and skip some steps, but the entire process, that's trying to get you in the mindset of fusing algebra with geometry. Okay? So we're going to do this one over here. They give the measure of angle LOE to be 84, and I love all the puns that they're doing. You've got love, you've got math. I love math. I've got angle dog and bog and daub. And then I've got Batman up here. So I've got lots of nice little references. So maybe that's a little more entertaining. Over here, I've got the measure of angle, well, LOV, angle LOV, plus the measure of angle VOE equals the measure of angle LOE. Okay? Angle LOE, the entire thing. And they're saying that LOV is 4x plus 1, so this quantity is 4x plus 1. Let me write that a little nicer. There you go. And this one is 5x plus 2. So I know that 4x plus 1 is measure of angle LOV plus 5x plus 2 should equal 84. So from here I can just solve it out and solve for x, but they want to know the measure of angle LOV, so we'll come back to that. So we're going to find x first. So I've got 4x plus 5x, which is 9x. Okay. 1 plus 2 is 3. So I've got 9x plus 3 equals 84. So now I'm going to subtract 3 from both sides of the equation. And I get 9x equals 81. So from here, 9 is being multiplied by x. So I'm going to divide both sides by 9. And I get x equals 9. And we're good. Measure of angle LOV. So since I have x equals 9 and I'm trying to solve for this angle measure here, what I'm going to do is down here, I know that the measure of angle LOV equals 4x plus 1. Let me just double check that. Yes. So since I have that x is 9 now, I can actually start to substitute that in. So I know since x is 9, I've got 4 times 9 plus 1. So that's substitution. 4 times 9 is going to be 36 plus 1, which is 37 degrees. Okay? So any way you spin it, you can start to figure some of this out. 37 degrees is LOV, so this is equal to 37 degrees. And if we want to take it a step further, which I do, I can find the measure of VOE. I know the measure of the entire thing is 84, so I can take 37 from 84 and find VOE. Or I can plug in 9 into that expression for VOE. So I'm actually going to do that because that's fun. For me. Maybe not for you. I hope it's fun for you. So I've got 5x plus 2. So 5 times 9 plus 2. And then 5 times 9 is 45. Plus 2, so 47 degrees. So 7 plus 7 is 14. 14 plus 40 is going to be 54. 54 plus 3 is indeed 84, so that works. Yeah. So just to make sure, measure of angle LOV plus the measure of angle VOE better equal the measure of angle LOE. So that is 37 plus 47 does indeed equal 84, and we're good. So I hope that helps. Again, I'm just trying to give you guys a little extra help and give you resources to go back to. And of course, you can always use their videos. I figured it would be helpful for me to do it on my page, and I can use those year after year to kind of understand what my thought process was the first time, some stuff that I can add to it, but I hope this helps make you a little more comfortable, and maybe you can ask questions about specific parts. So see you later. Thank you.